The registrar is always behind around here. It was only about 10 years ago they learned about computers in the registrar's office. You would think MIT is higher tech than that, but seriously, they were still doing things by hand paper documents from years ago. But okay, that should be all right. I'm saying that's not right.
You like soccer?
Well, my kids used to like soccer. Why? Someone playing soccer here?
No, I saw the soccer ball. So.
Oh, no, that was just, they only gave me so many choices. And they made me make a choice, as I remember. It's been a while since I set up this computer. But I have stories for everything. I have a story for... How many of you have children or have had children that have been second graders playing soccer? Anyone? Well, when second graders play soccer and someone kicks the ball over there, everyone goes running over there, okay? It's only when they get to be third or fourth graders that they learn. A few of them learn to hang back and do something else. But it turns out, oops, that's the wrong one.
They do that in preschool and kindergarten and first grade too.
Right, but it's up to second graders that they still are doing it at second grade, as I remember. So my story is when I was in second grade, I was at an Easter egg hunt on a soccer game, but someone says, "Oh, I found an Easter egg." And everybody starts running over there just like a soccer game. They all run over. And I was on the other side of the yard or whatever. And everyone was ahead of me, and I'm just looking at the backs of everyone's heads. And so I thought, as I was heading over there, this doesn't make any sense. There's a lot more eyes over there looking for that Easter egg that someone else had already found. And so I decided to go in the opposite direction and start looking for eggs where no one else was looking. And that was a very important life lesson for me. Okay, I made a career out of looking where no one else is looking. Okay, because if you try to compete with everybody else, you're not going to do well. You need to find something that, in fact, someone told me once, since this is supposed to be a welding course, one of the great metallurgists of our time was a guy named John Kahn. He's passed away now, but my first year on the faculty, I'd been working on a paper. I didn't have any research money or students, but I'd just been working on a paper of my own, and I didn't have, a friend of mine at Union Carbide, which existed back then, had given me 4 data points, okay? And I'd done some calculations. I wasn't too sure about what to do about it. And I asked John Kahn when I saw him in the hallway, I said, "Should I publish this?" And he said, "Get into a backward field. It's not hard to be a star." Now, he later denied that he ever said that, okay? Because he would think that other people would think that he got into metallurgy because it was a backward field and he was a star. But for me, I thought it was good advice, okay? And I've kind of held on to that. Okay, so we have how many people now? 13, was it? There's supposed to be 11 originally. And Tony, didn't you told me 11 originally? But then I thought I saw an email that we were going to pick up 1 or 2 others from somewhere.
I thought we were going to get another one maybe that, but I'm not sure if that's the case.
Oh, okay. Well,
I gave you their names.
yeah, the foreign guys they're not required. You guys, is everybody Navy? Any Coast Guards here? You're Coast Guard. Oh, you're from Greece. Okay. A number of the Greek students will take this, but some of the other foreign navies, they're not required to take it, so they don't bother. Okay. A lot of them are just doing the bare minimum, get along. You guys have 2 professors of the practice who are going to make sure you toe the line. Okay. And in fact, I've been teaching the 2N students. It's now 2N, but it was 13A back in the day when we had a Department of Naval Architecture or Ocean Engineering and Naval Architecture. But I've been teaching this since about 1985, or some version of this. Originally, it was not required, or what I had was not required because Professor Masabuchi, who was in course 13, which was Ocean Engineering and Naval Architecture, was teaching a welding metallurgy course. And so I started teaching a welding processes course, which was not required by NAVC. And people had to take his course, and they didn't have to take my course, but I told better stories, I guess. I don't know. Anyway, and then in 1998, when he finally retired from teaching, I ended up having to add welding metallurgy. So there's actually, you're going to see there's 3 modules in this course now, which are about 12 lectures each, and 36 lectures is what you would get in a normal 12-unit MIT class. None of you are MIT grads as undergraduates, are you? Okay. In all those years, I've only had 1 2N student who was an MIT undergraduate. And she was actually the leader of her class, the eldest one in her class. And it was very helpful to have her, for the class to have her, because you had someone who knew MIT. But none of you know MIT, so I kind of have, this had been taught during January, our independent activities. Anyway, I started teaching it during the summer about 15 years ago, so that I could help give you a flavor of what MIT is about. Because I came here 50 years ago this September, or this August, as an undergraduate, as a freshman, never been north of the Mason-Dixon line, grew up in Virginia, went to high school in Virginia Beach. One of my classmates' father was the new captain of the first JFK carrier being built at Newport News. I had no idea that that was a big deal, okay, when I was growing up. But I now understand that, I'd heard that later he made CNO, but anyway. In any case, this course it's become a required course, the required course that they use for the 2N students to meet the NAVC requirement. You're supposed to have, I think officially it's a welding metallurgy course, but to me there's a lot more to welding than just metallurgy. And so I just took what I had already been teaching on welding processes. And by the way, when I say welding processes, you're going to see that I start off with cold welding and adhesive bonding and diffusion bonding. Well, you know, those things apply to painting chips. How do you get the paint to stick? Okay, that's nothing more than adhesive bonding of a sort. So I just teach what I want anyway, because I don't really get credit from my department for teaching this, because you're in a different department. But you don't have to worry about that. I had my first contract ever my first contract ever as a young assistant professor was on welding heavy section titanium submerged arc welding, which isn't used. But in 1980, after the Soviets came out with the Alpha Sub and stuff, I was at a workshop down at David Taylor, Annapolis. And all of a sudden I realized they were trying to figure out how the Soviets had built these subs. First, how could they afford to? Well, they had a completely different economic system, so who cares? I mean, we would never build one. But there were some other problems, like some of the Naval Research Labs guys came up to me and said, how did they solve the stress corrosion cracking problem or the creep rupture fatigue problem? And I said, I don't know. Well, it turns out they didn't. And I don't know if you know the story of the Alpha Sub. After about 3 years, they just left them all at the dry dock, not dry dock, but the dock. And they quit going down because they were full of cracks. Okay. This is a titanium electroslag weld made not here, but at Oregon Graduate Center, because I was at this workshop at David Taylor Annapolis on welding of titanium, and all of a sudden it just came to me at one of the breaks. I said, "Oh, electroslag." Okay, and we could get into why I determined it was electroslag. We came back in the room right behind that wall. We made the first electroslag weld that had ever been made in titanium, to my knowledge, in the United States. The Soviets had done it. I found a paper in France where they had done it, but we made the first one. And I now know, now it's over 35 years ago, but I learned about, it was one of the only 2 times in my life I ever had need to learn about confidential or classified data. But I actually saw some of the stuff about how the Soviets built those subs back around 1980 or 81. And that is one of the ways they built it. And I think it's fairly well known now. It's not just, it might be that it was classified when I did it, but there's anyone looking at the literature would be able to figure that out today. So anyway, my first research contract was from the Office of Naval Research, and then I was funded by the Office of Naval Research for about 30 or 35 years. And in fact, about 1979, the Navy made a big commitment to me at MIT in welding, and that was really the main thing that helped me get tenure. Okay, so I've always had a commitment to the Navy for some of those things that they did to help me out early on. So that's why I teach the class. Okay. We're going to flip last year and this year we're going to what they call flip the lectures. Anybody heard of flipping the lectures? Well, nowadays people can videotape things, and I've been videotaping this class for over 25 years. And we actually put it on YouTube. So you get to watch the lectures, and then I will come in and give recitations, okay, where you can ask questions and stuff. So today is just an introductory thing. Anybody have any questions before I get started on the formal introduction? Okay. These things will be on Stellar. Go ahead. Yeah, Brian?
We had asked about, are we going to block out Wednesdays to meet, or is that going to change?
I can certainly do next Wednesday. If we go further than that, I don't think I'll be here the 2 Wednesdays from now, the 21st or whatever that is, 20th. That's part of the problem with my schedule, okay? So we can tentatively block out Wednesdays, but we may have to modify some of those things. And as I told Tony, we're flexible on all of this. You'll see that as part of this presentation, that we're flexible about how we do things. You guys are top of your classes from different places. How many went to the academy? Okay, so that's about typical. About a third went to the academy. The rest of you were at some other university. But it doesn't matter if you weren't the top of the Navy. They call them engineering duty officers still. Okay. If you weren't among that top, you would be at Monterey right now. Okay. And Monterey's been trying to kill this program, 2N now. Used to be 13A, but the 13A program goes back to like the 1870s. Okay, MIT's had this continuous relationship. And at the highest level, because a lot of the people who end up being chief engineer of the Navy went through this program at MIT. There used to be, when I started out here as a faculty member, half a dozen programs. You could go to Michigan for nuclear, EDO type stuff. How many of you are nukes? Okay, that's a little bit higher fraction than we usually have, but in any case, we usually have 2 or 3 nukes, and we used to have more foreign Navy people, but we usually have 1 or 2, okay? You'll find out the requirements are not great because most of you are going to you're going to be struggling in a couple of weeks in your math classes, okay? First, it'll be, oh, I studied that once, but I forgot it, right? Because you haven't used it. Well, okay, they're going to make you learn it again. And for the next, how many are in the program for 3 years here? All of you? One of you didn't raise your hand? Are you here?
2 years.
2 years, okay. There are getting to be more of the 2-year variety, okay? And some of those 2-year variety change themselves somehow to 3 years as they get here, but don't ask me how. I've never gotten into that. But in any case, a few of you will probably be leading some ship design program for the Navy. Most of the ship design people, the officers in charge of that, usually as commanders or captains, were graduates of the MIT program, okay? I used to be able to take naval architecture at Penn State, Michigan, where they also let them do nuclear engineering. Like I said, Berkeley has a good naval architecture department, but those of Monterey's been able to kill all of those. It's all budgets, right? Clawing back budgets. It also used to be 25 years ago that there were about 25 or 30 in your class at MIT. So that's just how budgets have gotten tighter and everything else. Okay. So structural materials is what I teach during the semester, and what's in blue here is specific to Navy, right? Blue, Navy, right? So far as that goes. The course during the semester is 3171, which is an undergraduate version. 3371 is graduate version. 2821, since you're in course 2, there's what people know about J numbers. J means joint with 2 departments or more, 2 or more departments. So 3371 and 2821 are J courses. They are the same course in MIT parlance. My assistant's Jerry Hill, and she's just down the hall here. My office is across the hall. Brian Homan, who have they met you now? So Brian did his PhD with me a few years ago on non-destructive testing. So if you have some questions about non-destructive testing, he knows a lot more about it than I do. Brian is a staff member at MIT here, but he's only involved in the course because he wants to be, and he helps me out with a lot of the administrative things. Have you learned about Stellar yet? Okay. So Stellar, no chalk. Stellar is the MIT site for information about courses. Is it ER or AR, Brian? AR. So Stellar is the MIT program, and each course you have to be registered in the course. The Stellar site, Jerry put it in today. It will be up tomorrow, but rather than hand out things, I used to come in with boxes full of paper handouts. Now you just go to Stellar, okay? And you should be able, well, I'm sure the registrar doesn't even know that we exist yet because first day of class is Monday, according to the registrar. But Jerry said the Stellar site will be up tomorrow. And there are various handouts. Tony should have sent you a little handout on leadership management and education at MIT, which is something I wrote 15 years ago to try to make sure Bob Brown didn't get to be president of MIT. He was the provost at the time. And he was, anyway, he's now president of Boston University. So it wasn't because I wrote that article. It was because Bob was a big enough jerk that everybody knew he was a jerk. And so someone else got the job. When he left to go to Boston University, I sent him an email that said, bye. Okay? It's a short email. Bob and I didn't get along that well. In any case, so for the 2N students, for all the MIT students, there are all kinds of modules on structural materials, and we'll see that. But for 2N, NAVC says you get no choice. You have to take welding, and we've added corrosion over the years, and you'll see that on the next slide. Okay. Oops. Hopefully you'll see it on the next slide. What's going on here?
So with the Stellar site, it'll be through your MIT email address, and I can send announcements when the class can be through Stellar. So that
Right.
if it changes from week to week, we would have.
So Tony and Brian can organize things. You don't have to do everything because Stellar makes it easy to do some things, okay? But since you guys didn't have it yet, that's why I sent the thing to you, Tony, before. So the other course you should sign up for is 2690, which is Corrosion and Marine Engineering. It's a 6-unit course. None of you know what MIT course units mean. Does anyone know? Have you read anything? Yeah.
Approximately the number of hours per week that you would spend on the course, split up between lecture, lab, and after-hours study / reading.
Right. So if you look in the catalog, MIT might list this particular course as a 303. The corrosion course would supposedly be the equivalent of 3 hours of lecture in a week, 0 hours of laboratory, and 3 hours of outside estimated work. And when you do evaluations, they will ask you to estimate how many hours you actually spent on the outside, okay, on this course. In this particular course, both the two courses, so you're actually signing up for 18 units. 45 units is a full load during a semester. How many, you've probably taken 24 units of math or something? And 18 units of this, that's a pretty heavy summer load, which is why I don't kill you, but I also don't kill you because of some of my philosophy on some of the stuff. There's a sign-in sheet which we passed around. We sometimes, although I haven't seen it, there are some students who say they want to take this, but I'm sure they don't know that it doesn't start, it started before next Monday. I do it early in the morning because I'm usually here by 7. I'm usually gone now that I'm past normal retirement age. I'm not retired, but I'm usually gone by 2 o'clock in the afternoon, folks. I don't like traffic. We're flipping the lectures, which means you get to watch the lectures on YouTube. One of my favorite evaluations was a student said he watched them while he fixed dinner at home. Okay, so you have presentations, and Tony's probably already talked to you. Anybody ready to do presentations this week? Did we?
I got it.
Okay, fine. We can talk about the we'll talk more about the presentations. You must view or attend 36 lectures, 3 12-lecture modules for you guys, plus 2690, which is another 6 or 10 hours of lectures. So this runs all the way in through August, so far as that goes. But we hope to be mostly done by the 4th of July, okay, with having to get together and things like that, because that's when you're going to be having math quizzes by the end of this month. The thing I tell the regular students during the term is we have flexibility in a stress-free environment. 95%, if you read my article on leadership and management, 95% of the pressure is self-inflicted at MIT. Whether it's on the faculty or whether it's on the students, it's people feel motivated. This is a place where you learn to work hard, okay? If you don't already know how to work hard. And most people already thought they knew how to work hard. I thought I knew how to work hard until I came here. But anyway, available modules, if you go to my website, you'll find that there's about 10 or 12 modules that I've done over the years, but you're stuck with NAFC's choice. They made a choice for you. Isn't it great? Okay. There's actually a story I just learned a couple of years ago about my father, who graduated from the Annapolis class of 44, but he graduated in 43 because they were running all the way straight through. They weren't doing summers at sea. They were spending 12 months going straight through. But at the end of the war, there was a Washington Navy Yard or something, and they were outfitting a new destroyer brand new destroyer that they had been building for the war, but now the war had ended. And this brand new destroyer was now going to go on a world tour. And in November of '45. My father came back from the war and married my mother, and they were expecting my older brother, and so he came back from, basically soup ship, or I don't know what they called it back then, but getting this destroyer outfitted to go on a world tour, and he told my mother that he'd quit the Navy because they told him, "You're going on a world tour and you will not see your family for 2.5 years." Okay? And he said, "Well, the Navy's not the right place for raising a family." And I'd never heard that story. But in fact, I have a brother-in-law who was in the Navy. My sister met him when she was at Old Dominion, and he was on one of the ships in Norfolk. And I told that story to him. He said, "Well, if the Navy wanted you to have a family, they would have issued you one." That was one of the sayings they had. I never saw that side of the things, and didn't even hear those stories until recently. But it was interesting for me to hear that my father gave up his Navy career so that I could be. Okay. Anyway, so there are other people during the term, and there's other parts of the structural materials course. Some of the 2N students will later take some of these courses because I've had students repeat this course 3 times, or repeat it twice for a total of 3 times, because if you take different modules, it's a different course. So this is a flexible course for everyone except 2N students. So there are also modules taught by other people. Dr. Jenkins was one of my students, worked on welding fumes, then he went off and got an MD. He's worked with Harvard School of Public Health, and he did, when I was on sabbatical, he did non-destructive evaluation of the human body. Basically, how does a medical doctor give an evaluation of people? And in fact, basically uses the 5 senses: sight, sound, smell, whatever the 5 senses are, in evaluating things. Certain diseases have certain smells, okay? It's not just bad breath, it smells like garlic. And then there's a guy who is a graduate of the Sloan School, who's a intellectual property lawyer in downtown Boston, and he teaches one on law and technology, which is what students need to know about intellectual property. Student requirements for this course for you guys, we're going to do presentations because I've been doing these for 30 years, and I learn a lot, and you can learn a lot from each other because you all have more experience than most of the students that I have during the semesters, okay? And I told Tony, I assume you've told him that the topic can be on anything you want, but we hopefully are going to do it on something that relates to the Navy. And it doesn't have to be welding, it could be corrosion, it can be painting. I remember one that was sort of new for me a few years ago. Anybody ever seen them use dry ice instead of sand to remove the paint on the ship? The advantage is, once you hit it with the dry ice powder and knock the paint off, there's no CO2 to pick up. It all evaporates away. And what you pick up is you have just that hazardous waste of the paint, right? So far as that goes. Let's see, there's various things, and I might as well. So you have to do a presentation. You only get 10 minutes. We typically do 3 in an hour. That means you should not have more than 10 PowerPoints, so far as that goes. So you do a 10-minute presentation, and we're going to start those sometime next week. So next week we'll do a recitation on Wednesday, and if anyone's ready, if you've got 1 or 2 that are ready on next Wednesday, and I think I'm free Thursday and Friday of next week, so if you're...
Those 13th and the 15th,
Yeah.
I've been putting out to the group.
Yep. Yeah, the 13th is Wednesday.
So Wednesday,
Yeah, if enough people are ready to do I'm not going to come in and give 3 hours of recitation, because you should try to watch 5 or 6 of your 45 lectures that you need to watch, and hopefully have some questions about some of those things. But if we're going to do 3 days next week, which is fine with me, then you guys are going to have to fill up at least probably 2 of those hours, okay? But 2 hours is 6 of you, so we'll be half done with your presentations. And your presentation is nothing wrong with taking something you did at your last duty station or something, where you might, I mean, people talk about they were at Yokosuka and they opened up this tank and it was full of corrosion on the inside and it was just supposed to be an oil tank. And why was the oil tank corroding? Okay? Oil is supposed to be a preservative, right? Anyway, so it can be on anything you want, and if you have some questions, then we can talk about potential things. I will be, since we're flipping the lectures, there's a little bit of a problem in that I like to bring things in to show people. You will hear in the lecture about how the Navy in 1946 was concerned about Liberty ships breaking up in the North Atlantic in the middle of the war. There's a famous picture of the Schenectady at dry dock. This is in most of your fracture books. This is the report it came from. This is a report to the Secretary of Navy in 1946. This is the whole report. MIT's library was throwing it out, and one of my students bought it for $2 and gave it to me. But it's an interesting historical book, okay? You've heard a lot about additive manufacturing now, okay? Well, back in the mid-90s, after peace had broken out with the former Soviet Union, the Naval Surface Warfare Center in in White Oak, Maryland, they've been working on particle beam weapons. Okay, they were going to shoot. They've been worried about the Exocet missiles and things wiping out the British cruiser, the Sheffield. You weren't even born then, but in the mid '80s, the Falkland Islands decided to, or the Argentinians invaded the Falkland Islands because they claimed them, but they're called the Falklands because the British had command of them. But so the British cruiser, the Sheffield, was hit by a French Exocet missile, and it wiped out the Sheffield. Now that's been a presentation 2 or 3 times over the years, is why did one missile wipe out a capital ship? Anybody know what the theory was? The theory was that the missile caused the aluminum superstructure to catch fire, and now the whole superstructure was just a fuel source, a great big flare, and the top of the ship just burned away. The steel structure was left underneath. But in fact, that's been disputed since then. But I can guarantee you that the U.S. Navy at the time thought that was what the cause was, because I was working at David Taylor Annapolis during the summers, and they were switching over all the ship designs from aluminum superstructures to waffle steel lightweight structures, okay? So the Navy wouldn't have been doing that if they didn't think that the Exocet had caused the ship to catch fire. I told Tony the story of the Belknap disaster, which most of you have never heard of, okay? But after the first JFK carrier, I think it was even on sea trials, but they were doing something with some of the other ships, and the Belknap destroyer rammed into the side of the Kennedy. Well, it wasn't that big a ram, but it turns out one of the elevators from the flight deck down to the, where they store the aircraft, the next deck below. Anyway, it hit one of the elevators. One of the aircraft spilled some of the jet fuel on top of the Belknap superstructure, and the Belknap aluminum superstructure caught fire and wiped out the Belknap. Okay, so we lost a destroyer, and the joke at the time was a gallon of jet fuel would wipe out any ship in the fleet. Okay, so there are some disasters that have occurred that you don't always hear about anymore, but some of those, they make nice stories. I probably had 6 presentations on the Thresher and various theories about that. But in any case, this sample the the White Oak folks had been working on particle beam weapons. These were going to be electron beams of million volt variety, or 5 or 10 million volt variety. They were going to shoot an electron beam through the air. And so if you have an incoming missile, this is better than the phalanx system, right? You're going to be able to shoot it down with a particle beam weapon that you could aim and everything. Well, they spent about $250 million on this, and they had a problem in that they couldn't get it to go straight. There's something called the hose instability. You ever seen a garden hose whip around when the water's coming out of it and no one's holding on? That's the hose instability in physics. And there was a hose instability for this beam of electrons, million volt electron beams. And so they could only shoot down missiles that were about a foot away. Okay? And it only cost $1 billion. So they had a workshop, 3-day workshop, and they asked me to come down and see if they could weld submarines together, trying to find another application for this technology, because otherwise they're going to lose their next $250 million in funding. And I said, well, with that much power, you could melt a submarine. You don't need that much power to weld a submarine. But I said you could try to, we didn't call it additive manufacturing back then. We called it solid freeform fabrication. So this is a piece that we made with electron beam back in the 90s of manganese, aluminum, bronze. Why manganese, aluminum, bronze? Anybody know what it's used for in the Navy? It's called propellers, okay? Excellent corrosion resistance, cavitation resistance, and things like that. So, and if you want a good field trip, if you guys ever want to take a field trip, would be to go down here to Walpole, where one of the state prisons is, but next to that is Byrd Machinery. And Byrd Machinery is where the Navy makes all their high-class propellers. And you could probably get a classified tour, okay? I could probably, the chief engineer is a guy named Frank Lanny, and I could call up Frank. And they've said they'd be happy to host you. I've had classes go down there. It's not part of this class, but if you want to go down there and see, most of you don't know about it, but in the 90s, Toshiba makes this 5-axis milling machine to mill the flutes of the propellers and stuff. Super accuracy to keep the noise down and things. And Toshiba sold one of these to the Soviets. Okay, this is why we have NOTARs and things like that. Okay, to not lose some of that technology to foreign powers. But you can see the Toshiba milling machine down there at Byrd Machinery, where they're doing U.S. Navy propellers. They do. I've worked on the Israeli Corvette propellers that had broken and things. Anyway, you have to do a 10-minute presentation on any topic you like if you have a problem picking a topic. Like I say, a lot of people just talk about things they had talked about on their last duty station. Any questions on the presentation? You shouldn't be too general. You shouldn't be too broad. Don't try to cover too much, but add your own analysis and opinions. I told Tony one of my favorites was right after the second Gulf War in the early 2000s, whenever it was. We had a group of 2N students, and they were doing the presentations. And one of them was on board a ship, a cruiser that during the attack, remember that attack only lasted for 3 days. But during the attack, I think it was on the first day of the attack, one of the Navy cruisers lost its 3,000 PSI airline because of stress corrosion crack in one of the brass valves. And it came offline. The admirals were not happy to lose a capital ship. Now, that war was only 3 days long, and it didn't probably affect the war, but in another war, it could. Well, so this student talked about what happened because he had been on board ship when this thing broke. And he had been one of the junior officers who had to go retrieve it and try to fix it and everything. Well, it turns out another student had been in the Philadelphia Naval Depot, and she had been given the responsibility afterwards to go and check what was in the naval supply chain. And she found that 30% of all the valves in the Navy supply chain in the Philadelphia Naval Depot were the wrong brass alloy or bronze alloy. and we're susceptible to the same type of problem. Okay? So they didn't know it. They were classmates. In this case, this was in January, they've been classmates for 4 or 5 months, and neither one of them knew that they had worked on different ends of the same problem. So you don't have a lot of time. We will take 5 minutes for questions and answers and talk about the various things. And anyway, there's no quizzes, no tests, no finals. I'm supposed to tell you if there's an issue with colluding with your classmates, and I don't think, well, part of my teaching philosophy, we shouldn't put students in the position where they can get caught cheating or they're encouraged to cheat. That's entrapment, is what the authorities call it. You'll be evaluated on your presentation and participation in evaluating others. In fact, you'll be in, MIT forces me, it's a rule of the faculty, that I can't give the whole class a grade. I have to give each individual a grade, which is one of the reasons you get to do presentations. I wouldn't even necessarily require it, except I usually learn a fair amount from some of the presentations. You should do, one of the other things had talked about, prepare a one-page outline of each of the 12 lecture modules. So you got 3 12 lecture modules, and what we ask is when you watch a 1-hour lecture, you provide 2 or 3 lines of what the theme of the lecture is. Okay? I once, it was in my junior year, first term junior year here, and I decided to take an elective course in the physics department called Introduction to Quantum Mechanics. Why did I do this? I don't know. It was a great class, except I didn't have a clue what was going on. I was getting 15s out of 100 on the homeworks whenever the class average was like 85. And so the night before the final, I thought, I'm just going to flunk this course. I don't have a clue what's going on. So I took the textbook, and I just said, I'm going to figure out what the high points are, and I'm going to go into that 3-hour final. Went into the 3-hour final, finished it in 1 hour and 20 minutes, checked it over in another 20 minutes, walked out of the class, and I got an A in the class. Okay? This was another watershed thing, just like looking for Easter eggs in my career. I said, you mean all the rest of this stuff is just fluff? All the stuff they talk about in class, there's only 2 or 3 key points in a lecture. And so I want you to watch the lectures and try to say, I call it guess my lecture. Most professors don't give you the outline of their lecture, but you got to figure out what it is they're talking about and what is the point, the 2 or 3 points. In 1 hour, you can only cover 2 or 3 things at most. Now, the interesting thing to me is I have the students turn this in, and I think it's just a good outline for how to figure out the course. Because for me, I never took another note in class after midterm junior year, both undergraduate and graduate. I basically just didn't take notes. I just sat there trying to figure out, what is this lecture all about? Okay? And if I could figure out and keep up with the lectures and understood them at this basic level or a high level, but not all the detail, I could go in those quizzes and ace them. Okay? So it's been true in the rest of my career, even when I'm not taking quizzes, how to just get the high points and figure out what's most important. And so I think it's a worthwhile exercise to make you do that for these lectures and turn them in. And as Brian will tell you, you read 2 students from the same 12 lectures, and you wouldn't believe that they were watching the same lecture, because what each person takes away from the lecture is what they understand. Okay?
And summaries are for us.
They're really for you. I mean, you have to turn them in, and that's the way I check on the students during the semester to make sure they're doing their work. I don't usually have to worry about 2N students. You guys are used to doing what you're told to do. Okay? It's just the way it works. Okay. But for the other students, I do need a way to kind of make sure they're actually even watching the lectures. Many students say they learn a lot from the course, and from the other students' presentations. My teaching philosophy is too much of our educational approach is geared to preparing students to take a quiz. What happened here is when my children were in high school and I get up at come down and eat breakfast at 4:30 in the morning. No one else is around. And one of them had left their high school math book on the kitchen table. And so I kind of eating my cereal and flipping through it. And that math book had 2 pages on exponentials, 2 pages on differentials, 2 pages on factorials. I had no idea that mathematics had been developed in 2-page increments. Okay? And I thought, all they're doing here is prepping them to take the SAT exams. They were not trying to teach them math. They're just prepping them to pass a quiz or do well on a quiz. So that was 20-some years ago. And as I thought about that, I started looking at what we do at MIT. And I think it stinks. I don't think it's designed to teach students. We're coaching you, and a professor will run through his lecture the day before a quiz because he's got to cover everything because he knows he put a problem on the quiz that includes certain things. And if he gets interrupted, anyway, he has to finish. I don't have to finish anything. I can stop and tell stories. You ask the question, I'll tell the story, okay? So MIT students do not need to learn how to take quizzes. Okay, so I'm not going to. Now, I have some international students who get very upset with my teaching method. They want to be able to show how they can ace the quizzes. Okay? Sorry, that's not what this is all about. Okay? So, a good teacher makes things simple rather than complex. And in fact, what I used to say is I'm trying to tell you what you already know and how to put it together to reach a conclusion. How many of you had engineering capstone courses at your universities, right? So a number of you that have a capstone. Well, this is my course ends up being sort of a capstone course for the seniors, where it's not just about welding. You're going to find when you go through the welding lectures that I'm talking about how light bulbs work and all kinds of things. But it's basically just teaching physics and helping you understand some of that stuff. So keep it simple. If you ever heard of Occam's razor, here it is in Latin that he wrote in 1292. Turns out his original keep it simple is not quite so simple. But most of the stuff is just, in the lecture, is just fluff or extra materials. As I said, you can only cover 1 or 2 concepts in an hour. The rest is fluff. Why do we give nice quizzes with nice numerical results? They're easy to grade. If the answer is 15 and they got 15, check mark right. If they got some other number other than 15, you got it wrong. So it doesn't take long to grade. But that doesn't mean it takes a long time if you. That's the Gettysburg Address, by the way, depending on your eyesight. To read what things that the students have written. So why would someone spend an entire lecture doing a derivation? How many people have been in a class where the professor spent the whole hour doing a derivation? Right? Why do they do that? Did you ever think about it? I learned my first year on the faculty, it's because they didn't have enough time to prepare a lecture. What happened to me, I had been on travel. I was teaching this graduate course on deformation processing, and I got in early in the morning, and I had to teach class at 9, but I had not really prepared the lecture. And I flipped through the book, and oh, there's a derivation. I can go do the derivation. And that's when the light went off. I thought, oh, I don't have to prepare a lecture if I'm just going to get up and do a derivation and make half a dozen mistakes, right, in front of the students, right? What's the point of that? So that's what I did. I did the derivation in class, but I swore to myself I would never do a derivation in class again. And so for the last 41 years, I have never done another derivation. If they need a derivation that's not in the book, I write it out on a piece of paper, I copy it, I give it to them in class, and I say, so here's the algebra of how you derive this. Let's talk about what it means, okay? So now you know the secret of why professors do derivations in class. Bunch of idiots. Anyway, sorry. Those are my colleagues. Well, communications. We won't go through some of this stuff because we're running out of time. Edward Tufte wrote a series of books on how to present things. He's a professor, was a professor at Yale, and I took his one-day course once, and as he said, fuzzy writing is usually the result of fuzzy thinking. And the rest of this, you can watch it because we have a version of this, what I've been talking about, if you wanted to watch the introductory. And it goes through and it talks about communications, a large part of what you need to learn. And actually the Navy does a better job than we do with our undergraduates and graduate students in teaching you communication skills. You call it view graph engineering, right? Or whatever, PowerPoint engineering or whatever. But not that I am the master of PowerPoint. I may hand out a Tufte article that he wrote in the New Yorker about PowerPoint, where he used Auto Content Wizard to do the Gettysburg Address in like 6 or 7 slides. And if you want to see a great piece of English or English literature or American literature turned into absolute drivel by turning it into PowerPoint, you are going to need to use PowerPoint. If you watch a lot of the rest of this, I tell the story about Lester Thoreau, who used to be the dean of the Sloan School of Management, and back in the 80s, he was getting $30,000 a lecture to go to talk to boards of directors and things, and how I learned that he wasn't saying anything dramatically different or things I didn't already know. It's just how he said it. Okay. So there's more that you can watch on some of that introduction, and I will bring some of these other things in. I have a piece of HY-80 welded. I have a turbine blade. I have a piece of the X-33 space plane. One of the things you're going to find as you go through the first welding lectures, and the order that I would do it is solid state welding, which starts out with cold welding, and then adhesive bonding, then fusion welding, and then welding metallurgy, okay, because that's kind of how I developed them. But there are 2 things you're going to learn there that inhibit joining. Ordinarily, if something's a solid and I put 2 solids together, they want to bond. But there's 2 things that keep them from bonding. One is surface roughness, okay? We like to think of a flat surface as coming together like this, but in fact, on an atomic scale, it's wavy. And so there's what we call asperity contact. This is only contacting at a few points. Less than 10% unless I squeeze it. And even if you squeeze it to the point where the whole thing, the metal is deforming, you still have 30 or 40% voids. And you'll learn why. You can't get rid of all the porosity. But the other thing is surface contamination. And the example I give there, which you'll see, is there's CO2 and water vapor and other things in the air. If I create a new surface by fracturing something, how long did it take? How long do you think it takes to contaminate that new surface with water vapor and CO2 and everything else? Instantly, we can be more quantitative than that, but that's right. 10 to the minus 8 seconds, okay? That's faster than a blink of the eye, which is 0.4 of a second, by the way. But it's called the Langmuir by Irving Langmuir, who was a Nobel laureate at General Electric Research in the early 1900s. He studied surfaces and other things, but the Langmuir is 10 to the minus 8 atmosphere seconds. So at 1 atmosphere, it takes 10 to the minus 8 seconds to contaminate a surface with 1 monolayer of atoms. At 10 to the minus 8 atmospheres, it takes 1 second. But 10 to the minus 8 atmospheres is a pretty good vacuum system. In outer space, it might be 10 to the minus 12. Deep space might be 10 to the minus 12 atmospheres. And so even out there, you're going to get a monolayer of hydrogen in 10,000 seconds, which is 3 hours, right? So we always have contamination, and the whole problem of cold welding, adhesion welding, diffusion bonding, soldering, they're all trying to overcome these two problems of surface roughness and surface contamination. Okay? And they just, so I've now told you what the first 12 lectures, or first 8 lectures are all about in a little sound bite. Okay? So you got to learn to summarize things. Any questions? Okay, we're done. Because your MIT classes go from 5 of to 5 after, or 5 before. Right?